Good afternoon, everybody. Colin did a lovely introduction. I'm Louise, very passionate about materials and welding, and usually materials and welding, not necessarily separate because you have to weld a material. And I'd like to present a bit how harmonization affected our latest revision of 3992. It went from AS NZS 3992 just AS 3992. But also how our industry, basically the way the industry's changed and how that affected the standard. So looking at the journey from the 2015 to the 2020 version, what harmonization aspects were considered. Then looking at welder qualifications, so sections 5 to 7, how that were changed. Looking at section 9, the welding procedure qualifications, and then welder qualifications in section 9. And then procedure qualifications for special welds. So of the biggest changes in the standard, most of that happened in section 8. And a bit of a summary and a conclusion. So 3992 from AS NZS to just AS. So it was originally updated in 2015. But there were quite a few items parked during the 2015 revision because there just wasn't time in the scope to get to them. So those issues were addressed here. But there were also several issues highlighted between 2015 and 2018 when we started the review process. And that is why we went from just a correction of the 2015 version to a full update. So address the parked items and the new aspects that came up. But unfortunately, New Zealand declined to officially participate. And they told us that Standards Australia just charges them too much. So one of the biggest changes in section 1 was the addition of a bunch of new terms. So actually defining backing gas, building up, buttering, cladding, process, a competent person, which is a big deal. In-service welding, overlay. Owner is also added for the first time. What a PWPS is, surfacing, and service exposed welds. So showing that our industry has migrated from a manufacturing industry to more maintenance and repair. So harmonization was mostly with ISO 15614 and ASME 9. A lot of the pressure equipment these days is fabricated offshore. So a lot of times the questions we deal with, oh, it's fabricated to ISO requirements because it comes out of Europe, or to ASME because it comes out of China. Can we actually accept these? Are these acceptable alternatives? And especially since ISO 15614 Part 1 was a unification with the ISO requirements and the ASME 9 requirements in one standard. And that meant changes on how you qualify procedures as well as how you qualify welders. So looking at welding procedure qualifications, there were significant changes to some of the essential variables. And I thought this was rather brilliant. You had a fillet weld there. There's an arc weld, Healy arc weld, staggered fillet. It's a bit of a MIG weld, and that's a plane. It took me, it's a MIG fighter spot. So table 5.1, under item 1, additional material combinations were now added, and also it's, which we'll get to the physical tables that shows that. And item 5, welding consumables. This actually changed to say that if you don't use a welding consumable within the manufacturer's requirements or within the standard it is actually supplied to, that procedure is not qualified. So testing of a procedure doesn't justify using it outside its range that it was actually designed to. And then under heat input, essential variables are now for each weld run. Because I actually dealt with a case where the manufacturer had specific requirements to meet minimum toughness requirements, maximum hardness, and he was very upset when his client's inspector showed up without saying hello, but went straight to where the welder was welding at 4 kilojoules per millimeter instead of 2. And he said, no, but the average heat input over the whole butt weld meets the requirements. So additional wording was added to make sure that it's per weld run. And then the creep range was added for the heat input for gas tungsten arc welding, which was previously introduced for MMA. And then the requalification range, the previous heat input range, if you don't have toughness testing, was plus 80%, minus 50%. And that's been narrowed down to plus 30%, minus 25%. So it's not as narrow as the ISO range of plus or minus 10% because people were going to throw tantrums. But so we narrowed it down to something more applicable. So you don't, the standard was so wide you could drive a bus through it. So it's a work in process to update aspects to meet the technical requirements. And then materials grouping, we've got a bit of an eclectic way of doing materials. So carbon steels are basically group A, B was just a bit of moly added, and then C was P11, and D had your D1 was chrome moly vanadium, but D2 is chrome moly, D3 is chrome moly, and then D4 is chrome moly vanadium. So I tried to convince the committee to go, okay, let's get a group that's just chrome moly vanadium, a bit more the ISO way of doing things in ISO 15814, FIT 508. But even though that standard's been now accepted in Australia, there was a big rejection of that. So we expanded B from just group B to B1, 2, 3, 4, and 5. So the old half quarter CMV material is now B5. So that is moved out of group D. And then, so the D1 is now only one chrome, so the higher chrome molybdenadiums. And then B4 is what's called WB36. It's a copper, nickel, moly, copper precipitation hardened steel that you use for power stations. B3 is at this point open, and then B2 also, but in B1. So we added in scope to adjust our classification of the standard a bit in terms of materials. And then so D1 is now, instead of having a big group D1, it's now much narrower in terms of just the higher chrome molybdenadiums. Because there's differences in how you deal with the higher chrome molybdenadiums versus half quarter. It needs a bit of special love. So this is the procedure qualification table that we know and love. I tried to update this to what we wanted with the ISO. But with our way of classification, because our classification, as I said, is a bit eclectic, it sort of grew organically over time, and it wasn't to the same, it wasn't updated the way that ISO was. We kept this, but also added in, oh, I think there, added in the B1, and so added B5. So just added in the ones that changed, but kept the format of the table exactly the same. And instead added this table 5.3b. So now you can see your group 5s, your chrome mollies, chrome moly vanadiums, your ferritic stainless steels, austenitic, nickel steel, duplex, and expanding the qualification range. So the 3992 now allows you to weld the procedure, and you have so many more expanded qualification range, especially for your higher low alloy steels, where previously this table more focused on carbon steel and a bit of the low alloys here, but not much. We also added in the nickel alloys. So now nickel to nickel, as well as nickel to carbon steel and nickel to your low alloys. So that now you can actually qualify, instead of having no qualification range, if you weld this nickel to that low alloy, that's what you're stuck with. Now you actually can weld much more with it. So in section 6, test pieces, this is what we're trying to prevent by qualifying. The good thing is that table 6.1 was updated in the previous version with a number of test pieces, so there were no significant changes to that. But note 3 was added with hardness, is that hardness now may become a requirement depending on your application. So we added information around hardness. And then note 16 said that specifically, if you've got a load-bearing fillet weld, these now need to be qualified with a butt weld. So you can't just qualify a fillet weld that's load-bearing, for example, a lug, with just a fillet weld. So that is pretty important because of some failures that happened over East. And it also requires you to consider service conditions when you're considering repair welds. So service conditions also have to be taken into account when you're looking at weld aspects. So it's not just, oh, I've got one procedure that I'm going to apply everywhere. This is that procedure, even if it's qualified to the standard, does it meet the application requirements? And sometimes the answer is no. And then there's the post-weld heat treatment in section 6.4 was modified to take into account the new materials groupings. So instead of just D1, F, G, H, J, K, L, M to be considered, you have to consider B4, B5, D1, D2, D3, D4, F, G, H, J, K1, K2, L, M. So expanded to accommodate that. And this is the slide I was excited to share. This is what it comes in with Peter in terms of, and the question also that was there for pickling and passivating on site. Appendix I was added to accommodate what do we do with site welding. So you've got two ways of dealing with stainless steel in terms of whether for service to make sure that it meets the requirements. Either you have some effort before welding or you have some effort after welding. So you don't have to pickle and passivate if you can meet requirement number 1 and 2, and in some applications 3, which is your residual oxygen content in your backing gas. So either you put in the effort to have backing gas and you remove all the residual or as much of the oxygen as possible, and you get to that level of cleanliness, or you have to work some way on how to pickle and passivate. And both aspects have their challenges. I do understand that. So this actually comes from AWSD 18.2, and it's in AS/NZS 1554 Part 6. So it does look familiar. Level 1 is 10 ppm of residual oxygen, 2 is 25, 3 is 40, 4 is 100, and 5 is 200, then 6, 500, 1,000 ppm oxygen. So you can see how incredibly reactive stainless steel is at high temperature to oxygen. And what happens, this discoloration is an oxide. Somebody very smartly said, oh, but that's a chromium oxide. Why is it, what's the problem? I said, well, it's a high temperature oxide that has no corrosion resistance. It's not a passive layer, it's actually a very active layer. And that's the reason why you want to remove it. So hopefully this answers the question. Happy? Yep. In terms of mechanical testing, there were some changes. So interestingly enough, I thought that they removed the phrase, the responsibility of testing is the responsibility of the manufacturer. And when I discussed this with Bruce Cannon, he said that's actually because the onus is on the purchaser or the asset owner in terms of the contracting aspects to ensure that the procedures are sufficiently qualified. So because there's a lot of, for lack of better word, politics on how Standards Australia sees standards and how they manage projects and choose projects, that they wanted to, their wording is they remove motherhood statements. So stating the obvious. They want they want everybody to understand that the owner of the asset is ultimately responsible for what happens to that. So that means if you're the asset owner, you're responsible from everything from manufacturing to operating. It's not the fabricator's responsibility in terms of managing repairs, it's your responsibility to manage the fabricator. So it's a big change that's happened, but it's sort of snuck in under the radar a bit. And then mechanical testing for welding procedure qualification is actually to AS 2205. Now 2205 was on standards to be cancelled because there wasn't enough technical people to review them, so they just reconfirmed them. But all of our testing to 3992 should be to AS 2205 because that's the standard referenced, even though a lot of companies do testing to ASME. So you'll see testing to ASME for this, NDT to ASME. While that may be applicable, the standard still says 2205. And the thing to be noted is that 2205 is slowly being changed over to the ISO standards for testing. So that is also, so not all the ASME testing stuff may be applicable going forward. Sharpie V-notch testing changed a lot as well. The number and the location of tests would change, especially with the thick components. We'll get to that in a moment. So for different areas, with the notch location specifically recorded. Previously, you did one test here on the bottom and 2 on top. And now to test a location, you do 3 sets per location. So at the weld root and in the has, center of the weld and the has, center of the weld and the has. And if you've got dissimilar metal welds, you test both heat affected zones. So this just clarified it and brought a bit of sanity testing to toughness testing. Because what happens sometimes is that with the one test here in the roots, if that failed, what do you do then? So you didn't have a set of 3 to actually see, is it just one value that's a problem, or is it a value, or is it specifically that area that's a problem with the whole procedure? Oh, sorry, there we go. And then toughness testing was also, the requirement for that was there was a correction for the low alloy steels. Now, because 1228 was updated and 1210 at one point will be updated, this graph coming was actually added. So these lines, so that's the welded group E, and the B1 was added, and then the group B for post-weld heat treatment, and the as welded. So you see that's B1, but B5, the half quarters, is not there. That would be here. So this is a bit of a design. So 3992 was a bit of a workhorse because we added in things that needed to be updated out of 4458, which is woefully out of date and frankly incorrect in places. Stuff out of the 1210 was added in because there isn't the scope to update those procedures in the near future. So a bit of design aspects was added in the standard itself. And then also the notes were changed for the impact testing, is that originally it said that if you actually, for boilers, you don't have to do impact testing. And there seems to be this industry perspective that if something is operating at a high temperature, it's infinitely ductile and perfect toughness, and you never have to worry about it. But under creep applications, you actually lose your toughness. So you have to now qualify, well, no, I have to. I would like to have to, but qualifying with toughness testing actually ensures that your procedure and your welder has the best possibility of delivering a product that meets the requirements, and not just in the short term, but in long term, because we're talking about long-term properties. And then it has a specific note for creep applications that toughness testing for new build will be required. So there's been a growing understanding in the pressure equipment and the high temperature space that toughness testing isn't something that you only do for brittle applications or for cryogenic. And something that was added, as I said, the hardness testing. So the introduction here was removed. It's saying that, oh, hardness testing, remember there was a little introduction where the hardness testing says it's so difficult with materials chemistry and processing to say. And now a method was added and requirements. So this little table was taken from 15614 with the change here to the non-post-weld heat treatment hardness of 350. The ISO requirement is 380 hardness Vickers, but we followed the 1554 requirement that in the as welded condition we don't want anything harder than 350. But everything else is for the different material groups. And you can see where there's a line, it doesn't mean there's no requirement. It means that these materials you don't use in the unpost-weld heat treated condition. I wanted to add that line into the standard, but they said it was overkill. So, welder qualifications, and this poor welder had a misunderstanding with his bride. Looked at the incorporation and the acceptance of ISO 9606 parts 1 to 5. So all of those qualifications for welders, sorry? 2 minutes. Okay, almost done. Not quite. Oh dear, okay. I'll do the welder one and then I'll finish. So that was accepted. And then the qualification with ASME 9 was discussed in length, and it was found that with the level of testing and everything, that ASME 9 will be accepted provided a 3992 production test was done. And I just want to say this table was updated, which was previously wrong for the positions. But I want to get to this table because this is the part where we had from 2 negative comments from people requiring that you do bend tests for gas metal arc welding and flux core arc welding. And we've had 2 comments coming back saying, oh, this is going to kill industry to get a welder to do a bend test with flux core and with MIG welding, gas metal arc welding. And almost every other person in the, for example, in the seminar that I was running that was working in a test facility said that welders can pass the radiographic testing with MIG and flux core and they'll fail the bend test, which is why this requirement has been brought in. So if that answers your question, Neil. Doesn't answer your question? Well, that was... I'll wait to the end. You'll wait to the end, okay. So that was the big requirement, is that fracture toughness, bend testing in the notes is actually added for the processes that are susceptible to lack of fusion. And then requirements were put in for your special welds, which I'm going to skip now, but for your welders need to be qualified to actually weld these special welds. So the special welds are the repair section, and this section is the biggest update. So defining what's a buttering, building up overlays and cladding. And what I want to get to is that a table's been added, and this is out of ISO 15614 Part 7, so that you now know if you have an overlay, what type of testing do you need to do? Because the previous section was, previous chapter was very wordy without saying much. Now you've got a table. You see, I can exactly test this. And if you do hardness testing for hard facing, you know you need your top hardness. For others, you need this at a slant so that you know what's happening in your heat affected zone, fusion layer weld. And then you've got a range of qualification for your parent material. So it's not just I weld one thing with a build-up and what do I do now? You actually can qualify a range and a range of thickness depending on your parent material. And not just plates, but pipes on the outside and internal, and then how to section them for your test pieces. So, and there's a big section added on weld repairs to service exposed pressure equipment and a whole methodology. And the interesting thing is when you look at this methodology for repair, the first question is health and safety, and what supports do you have to look at? The means of removing the defect, cleaning of the weld. Welding procedure methodology only comes in number 5. And how do you sequence your beads to minimize residual stress? And finally, when heat treatment, removal of all the different issues, the defects, how do you inspect it, what's your acceptance criteria, and in the end you come to, okay, once we have all this established, do we have a procedure that's qualified to meet these requirements, or do we have to qualify a new one? And you have to take in your degradation properties into account, corrosion issues, fatigue issues, creep issues. So you can't just say, oh, I've got a procedure that I used on perfectly new material, welded 10 years ago, and this is perfect for weld repair. It doesn't necessarily work that way. But it gives you a structure on how to approach that. And that's the summary, sorry. Summary, changes, harmonization, affecting qualifications. Thank you.
Just time for one quick question.
Neil, yes, go for it, Neil.
So, I think it's going to cost industry a lot of money. To qualify a welder with NDT, just about $100, $120. Mm-hmm. And ASME and the previous edition of 3992 were very clear, short-circuiting GMAW processes and metal poured flux core processes had to be done ultrasonics. They didn't accept radiography. This new edition says that those two processes in its entirety must be done with mechanical testing. Now, if you're in Karratha or Kalgoorlie or any other regional part, if you're not in a major city, you've got to do your coupon, truck it down to somewhere. It's going to take days to get those results. Yet the standard and the industry then allow us to use those same methods of NDT that you won't allow to qualify a welder to test the real thing that gets energised. So it's not harmonised with ASME 9. And the standard says, we'll accept ASME 9 if you've got successful production welds in 3992. But if you're a new start welder, you're not going to have that history. The organisation's not going to do that. Then we've adopted, transition from 2980 to 9606 Part 1, which allows these NDT methods. So I feel that the 3992 direction is not in line with ASME, and it's going to cost Australian industry millions in downtime, waiting for welders to get qualified while we truck samples around the countryside. And you can't do a production test either. So if the welder's been continuously, doing a good job, they're going to do another coupon and send it away. So I think this will push the shift to 9606.1 that allows the NDT and the generous and quite clear extensions and revalidation, whether it be the Japanese system, the US system or the European system, but to all of a sudden to turn around and say, we don't trust ultrasonics and radiography when we've done it for years.
That's specifically RT.
And UT. You cannot do any NDT on flux core or GMA processes to qualify the welder. and that's going to hurt our sparse population.
But the one thing, I mean, a bend test is a bend test. It's one of the easiest things to actually get done. You have a hydraulic press, you cut a sample, you bend it. If it fails, then it fails. If it passes, it passes.
So our clients require NATO accreditation.
Yeah, no, that's where it comes in, and you don't have NATO accreditation out of all this place.
20 years, NDT has gotten better. We've got LED viewers, we've got digital floor detectors, we've got 9712 certification. Nearly all the laboratories have to be NATO accredited. So I would say that NDT is moving in a more robust, higher level of confidence, and the standards moving away as if the NDT industry has done something bad. So that's just a personal view. It's going to cost industry that's in regional areas. And if you're a mechanical test lab in the seminar that you said, of course they're going to do these ones. They're going to go, great. Now we get to do the qualifications and get the money for anyone that's welding flux core and MIG, which are highly utilised processes due to the high deposition rate.
Valid comment. Thank you.
Okay. All right.